Okay, we have reached the fun part, which is the coding. I hope it's fun for you guys because we are going to spend a lot of time in the coding section. We are going to start off by a script which is really simple, the move script. I open it up in Visual Studio and I've created as much comments as I could. I've written comments above my methods. I have written comments above my classes so that you guys can understand exactly what each part of the code is and what it does, what it's about. I hope that these comments can help you understand it if you want to download the code from the GitHub. The reason that I'm not writing all these codes again is that our focus here is the artificial intelligence, and these codes have nothing to do with AI. These are the standard codes that we write for any 2D game that we create using Unity. That's why I want to focus more on the AI part instead of the parts that are familiar for game developers. But I want to show you how it works either way. Okay, in my move class, I have a require component type of rigid body, which will tell the game object that this script is attached to that we are going to need a rigid body. So it says that this component is necessary for this script to work. That's why we have created require component. After that is my public variables, which is public float speed. I made it public so that I can change it using the inspector in Unity. The next part is my private variables, which I have my rigid body here. And then the next part is my methods. So here I have my await method, which is run before the first frame in Unity. In the await method, I have cached my rigid body. So I have my move character method that takes a parameter of direction as an int. I have my current direction default to 0. If it's less than 0, it means it's -1. My player will go left. If it's more than 0, it's 1. It means that my player will go right. And if it's neither, it will just stay 0, and it means that it will stay where he is. So the rb.velocity code is the one that does the magic. It's a new vector 2, and on the x-axis it will multiply the speed variable that we have set above by my current direction, which is either 1, 0 or -1. And I don't want any speed on the y-axis, so I'll just leave it at 0. That's about my move method. It's a very, very simple method. The next script is the shoot script. Again, I have my public variables, my private variables, and my methods. My public variables are the shooting position, and that's where I start shooting, which is my tip of the barrel or tip of my gun. I have my bullet object, which is the prefab of my bullet. I have the shoot delay, which is the delay between each shot. And in my private variables, I have a boolean of can shoot. So it will just detect if we are in between the shots, between the shoot delays or not. I have cached my coroutine, which I will show you in a minute. I have my bullet radius, and I have my circle collider 2D, which I cached in the await method. So in my methods, I will set my bullet radius to the radius of my collider. I have a public float get bullet radius, which returns the bullet's radius, which is always the same. And I have a method called shoot bullet, which actually shoots the bullet from the tip of my gun. So I have a direction, and I have a boolean to see if it's the player who's shooting. Inside the method, I check if I can shoot. So if I am not actually in between the shots, I am not in the shoot delay. I create my bullet using the instantiate method. And so I create my bullet object prefab at the shooting position, tip of my barrel, and I will get the reference of my bullet manager from the created object. And I will call the bullet manager's shoot bullet method, which will actually shoot the bullet in the direction that we want. After that, I have my coroutine, which is the shoot delay coroutine, which disables the shooting method for 0.4 seconds. You can obviously change that. The next method is disable shooting, which is the coroutine that we call. What it does is simply sets the can shoot boolean to false, and it will again reset the can shoot to true. And the last method simply returns my can shoot boolean. Next is my player manager. My player manager class manages all behaviors and components which are attached to this game object. So I have all my inputs here. As you see here, I have my two components, shoot and move. I have cached them in my awake method, and in my update method, I get the inputs from the player. So I'll say if my move manager script is not null, my direction is going to be my input.getAxis raw, which is going to be my arrow keys, and my move character method will be called on my move manager script using the direction that I've got from user. Next is the shooting script. Again, if my shooting script is not null and I press on the space key, my shooting script will be called on shoot manager. So I have shoot manager dot shoot bullet 1 and true. 1 is the direction that I'm shooting, so I'm shooting from down to top, which will be +1. If I was the AI, I would have written -1 here. And the second parameter shows that I am the player. So in the case of AI, I will write -1 and false here. The next part would be my game manager. My game manager is nothing complicated either. So I have public variables, which is my player score and enemy score. I have used TextMesh Pro. I have used a singleton type of class here. If you do not know what singleton is, I suggest you look it up. It's very useful in coding. The next part is the private variables, which are the player's current score and the enemy's current score. And in the awake method, I have these 5 lines of code, which are the standard codes for singleton. The next method is add score, which is called when player or AI actually hit the other one with the bullet. So if it's my player, I will increase the player score. If it's the AI, I will increase the AI score. And in the end, I will call update UI, which will update the text mesh that are on the canvas. So I will update my UI. The last piece here that I've almost forgot to mention is my bullet prefab. In my bullet prefab, I have a sprite renderer, which is simply a circle with a red color for my AI and a blue one for my player. I have a circle collider, a rigid body, and I have a script called bullet manager. In my bullet manager, I have a speed, 2 colors, which will show the color for each player. So if it's the player who's shooting, it will show the player's color, which is blue. And if it's AI who's shooting the bullet, it will be red. My private variables will be my rigid body and my sprite renderer, which are cached in the awake method. And I have a private boolean, which shows if this particular bullet is my player's bullet or the AI's. I have a method called shoot bullet, which is really close like the one in the shoot script. Inside the method, I will see if it was my player who shot the bullet, and then I will add the velocity to the bullet, so a 0 to the X and the speed times direction for the Y. And after that, if it's the player who shot the bullet, I'll change the color to player color, and if it's not, I'll change it to AI color. In this method on enable, I will say destroy this game object after 3 seconds. Last but not least is the untrigger enter 2D. It will check if this bullet actually hits someone or not. First of all, it will say if it's the player who shot the bullet, so I have to look for the enemy. If it hits the enemy, I call GameManager.instance.addScore m is player, and I will destroy the game object. And if it's the player, I will do the same thing. In the end, I have a Boolean method called isPlayersBullet, and it returns if this bullet is my player's or not. Alright, that's about that for the scripts. The only thing that remains here is our AI manager, which is the brain of our enemy, and which is something that we're going to talk about, right? So in the next lesson, we will go through some theories to see what exactly is an AI, how it works in the world of computers and all, and we will get into the coding very soon. See you in the next lesson.